the reverse the integer, as we are given some of the inputs, and the expected outputs are written over here, as they just want the reverse of the number. In case if it's dividing by 10 as 120, 130, then they don't want 031 or 021, they just want 21, not the 0. That similar case goes with the negative numbers, and they have also given us the range of numbers. If the reverse digit overflows, then we will return 0. Okay, so this is the constraint given. Okay, so this is our answer. Before coming to this answer, we will first dry run it. Okay, so this is what it is. As first of all, we are having an answer equals to 0, which will store the reversed number, and we are using while loop, and inside that we have returned this, and last we are returning the answer. So first we will dry run as step 1, x is our integer is 1, 2, 3, and digit equals to x divided by 10. This is what the syntax inside the while loop goes like, as we don't want x to be equal to 0. If x is equal to 0, then it will direct print that the number is not available. If it's not equal to 0, then the loop will iterate, then the loop will apply. First of all, we will check for the overflow, underflow before updating answer. We will see that whether the revised number or the x we have taken, the integer number, comes inside our overflow or underflow. If they are, then there will be certain conditions applied on them. So first number is 1, 2, 3. What we have to do is we have to just reverse the number. So first we want the last digit of the integer we are taking. So we will just divide that number 1, 2, 3 divided by 10 using this modulus. It will give us the number 3. It will give us the number 3. Before revising, before applying this, there was no remainder. Okay, before there was no remainder. So remainder equals to remainder into 10 plus digit. What was the remainder? 0 into 10. Into 10, it will have 0 plus 3 equals to 0. And x we will divide it by 10. So this number is divided by 10. We will have 12, not 12.3 but 12, because we are having this sign over here. As you are familiar with the difference between this sign and this sign, this modulus will give us the remainder, and this will give the value before the remainder. It will not take the remainder as value after decimals. It will not take the decimal values. It will take the numbers before decimal. So yeah, what we will do first is we will extract the last digit, and then we will check that before the first iteration were there any iterations. If not, then we will simply multiply 10 into the revised, into that remainder if it had, and then we will add that digit, in case what will happen, we will get to know after the first step. Okay, the second step is 12. So it is updated as 12. Okay, and then after having 12, we will again divide it. We will again have iterate an operation of division on it, and we will extract the last digit of this number of 12, which is 2, and then we will have this revised. What was the x previously? It was 3. Okay, so here it was 3, and then 3 into 10 plus 2 equals to 32. Okay, so just see the steps, how are they going. As first we are taking or extracting the last digit of the number on which we want to perform the revised integer, and then we are having the remainder of it. If the number is divided by any number, is there any remainder? We are storing it in rev. Okay, so 3 into 10, as this is 3 into 10 plus 2, as the digit was 2, so 32. And then we are dividing 12 by 10, which will come 1. As I have told you that this sign will not take any decimal values, it will only take the whole numbers. And third step is also followed by same. The last digit is 1, dividing by 10 will give 1, and it's 32, as previously it got 32. And then by applying this formula on this number, we will get 3 to 1 and x equals to 0. The same format will apply in the negative numbers. Okay, so let's go in the code. We will have, as we have seen that we are performing this function when we will extract the last digit, and if answer is greater than int max. Int max is something, a number defines the range of it. Okay, and if int max is divided by 10, or this is an OR operator, answer equals to int max divided by 10 and there are two operators used here, or and it means that if this not, then this must be, and inside here both of these values are considered. Okay, so we will return 0 as overflow. If answer is greater than the range we have defined, it will automatically overflow, as we have to check overflow or underflow before updating our answer. And if it's less than the number we have assumed or we have defined in our range, then we will proceed with our code, as answer is then having the answer into 10 plus digit, and then we are updating the values of x after later. In the second step, we have then extracted the last digit of the remaining number, and then we have divided, as you can see that the answer of the previous one of the first step is then revised here into 10 plus digit. So this is the dry run code of this one. These are the conditions, as we have to check whether the answer is being overflowed or not. And then after all, we will return this answer. We will return the answer, and if not, we will return 0. Thank you.